Hello class, this is Ms. Chikoy. So this is just a practice problem. So for the following circuit, which I'll give you in a second, find the equivalent resistance. 2, find the current and the power. 3, find the loop rule or rules. 4, find the junction rule or rules for the following circuit. Alright, so here's your circuit. I changed the resistances to make it a little easier. So this would be 5 ohms, 10 ohms, 10 ohms, 20 ohms, 20 ohms, and 10 ohms down here. Alright, so remember, find the R equivalent, the current, the power, and let's call this a 9-volt battery because that's what you were most likely going to be using, power, and then do your loop and junction rules. Alright, so now that you've tried it on your own, first step is finding your R equivalent. So to find your R equivalent, remember you've got to take the smallest piece. So if I'm looking at the smallest piece, I would add up these. So looking at them, you can tell that they're in series. So I would put 1 over 20 plus 1 over 20. See, it adds up nicely. So you got 2 over 20. Do the reciprocal. You get 20 divided by 2 gives you 10. So this entire thing gets replaced by a 10 resistor. And I am going to redraw it. So this is my new 10 ohm. Everything else stays the same, which you'll notice looks like it's going to work out in your favor. Alright, then we do your next ones. You can do both of these together because look, we got 2 in series, so you can just do them one step at a time. Hopefully you can tell that 10 plus 10 is 20. So this is still 5 ohm. This is now a 20 ohm, and this is a 20 ohm. So again, these are in parallel. Oh wait, you already added 20 ohm plus 20 ohm. You know that if I do this again, that's going to be 10. So you're going to have your 1 resistor here, that's 5. This is now, that's 1 over 20 plus 1 over 20, gives you 2 over 20. Flip it, 20 divided by 2 gives you 10. So this is now a 10 ohm resistor. This is still 5 ohm. Now it's a straight series, so we can just add it. So it's 15 ohms. So your R equivalent for this is 15 ohms. Alright, so now that you found the R equivalent, it's 15 ohms, you now want to find your current. So if you remember, current is equal to, well, I actually have it memorized this way, so it's going to be volts over resistance. Remember, this was a 9-volt battery. So we have our resistance, we have our voltage, so we can just put 9 volts over 15 ohms, and you get 0.6 amps. Next thing is you want to find the power. Power is equal to the voltage times the current. That's why it relies on both the amps and the volts to determine if an electrical current will kill you. So again, we know the volts. We just found the current. Multiplied together. And you get 5.4 watts. So remember, power is measured in watts. Alright, after this, remember we are doing the junction and loop rules for this. So let's start with our loop rule. Alright, so you can see I've drawn 3 loops, one in red, blue, and green. So the red one goes up through the top, takes the hallway, and then heads back. The blue goes for the bottom loop, but it again has another choice, so it chooses the top one. And then the green goes through all of the possible bottom paths. So remember, we know it's a 9-volt, so we can start saying our 9-volt is going to be equal to 0 after we subtract. Let's start with our red one. So it's resistor 1. So we can call this voltage 1. And then minus, we hit our resistor 2, so it's voltage 2. And we also hit our resistor 3, so that's our voltage 3. And at the end, of course, it must equal 0. So we do our second one. So now it's on the blue. We have, it still hits that first voltage because it's in series. Now, since this was a parallel, it goes a different route. So it next hits the R4, so that's voltage 4. Then it hits our R6, so that's the voltage 6, for a total of 0. Then our last one is in green. Again, it still hits that first one consistently in series. Alright, it changes up. Instead of 4, it hits 5. And since 6 was in series with 4 and 5, it also ends up hitting that resistor 6 for a voltage drop on the 6. So if you do these, you'll notice you see a lot of commonalities. So if you know at least some of these, you can cancel them out and add them together. Systems of equations. Algebra, this is why we have it. Which we will start to go over tomorrow, how you can start to solve these things and piece them together. Alright, so those are your 3 loop rules. And then we need to do the junction rule. Or actually rules in this case. So when you're doing this, you actually want to get a new current every time you have a split. So this is our first current. Then you'll notice we have a split. So let's make the first one I2. So this goes through both R2 and R3. However, since it hits both of them, your current will not change. Alright, the bottom one is a little more tricky. So notice it splits immediately. After it splits into 2 more. So this is, we call this our I3. And then this is going to have a separate current. And then it will have a different current back here. And then at the end of it, it will have its own different current. So your junction rule is for every junction to find a different rule. So remember, the basic rule is all currents in must be equal to the sum of all currents out. So let's start right here. So the only current in, remember, it comes from the top one. So the current in, we start with I1 is equal to, so now we want to look at the currents out. Notice there are 3 currents going out. We have both I2, then we have I3, and then we also have I4, because that is also part of the junction. So that's our first one. Now, we go to our next big junction. Most likely, I would call it this one. So you can see going into it, we have I3 and I4 going into it. And this is all equal to I5, which is the one that goes out of it. Alright, and we gotta find another junction, okay? Here is another junction. So this is all part of I6. So all of the currents going into it are I2 is going into it. Then we have I5. Remember, I3 and I4 no longer exist. They already combined I5. I5 is going into it. And this is all equal to I6, which is going out of it. So these are your 3 loop rules and 3 junction rules. So if you really had trouble with that after listening to the explanation, try to erase it, come up with that on your own, and try it again. These are what I expect you to do to get your basic grade on your test. And then we will go into how to make it more complicated and how to actually solve per voltage per current. Alright, hopefully this was informative, and I will see you tomorrow.